Hello, welcome back to this class. Let's consider factors and multiples. Very good. So today we are going to be looking at factors and multiples. And here are the subtopics that we are going to consider based on GSS 1 Mathematics first term. So we are going to be looking at this subtopic, starting with definition of factors and multiples. Then how to find factors and multiples, prime numbers and composite numbers. Then we look at prime factors and prime factorization. Then we have common factors and highest common factors, which is HCF. We have common multiples and lowest common multiples, which is LCM. So right now we are going to begin with the first subtopic, which is definition of factors and multiples. Very good. You need to know the difference between factors and multiples. When we are talking about factor, for example, the factors of a number, let's say the number is 6. So, are all the numbers that can divide 6 perfectly, such that they will leave no remainder. All the numbers that can divide 6 without any remainder are the factors of 6. Good. But when we are talking of multiples, these are the numbers. Okay, let's say multiples of 6. These are the numbers that 6 can divide. There is a difference between what you can divide and what can divide you. So let's see it on the board. Factors. The factor of a number. Let's say the number is M, let's say generally. So the factors of a number M are the numbers that can divide M without any remainder. So any number that can divide M without any remainder are the factors of M. For example, let's see factors of 6. Factors of 6. What are the numbers that can perfectly divide 6? Yes, the factors of 6 start from 1, as simple as 1. 1 can perfectly divide 6 without any remainder. Then 2 can also do the job. Similarly, 3 can also do the job. So 4 cannot do that. 5 cannot work. Then 6 is the next number. And that is all. Once you get to that number itself, so there is no other thing. So these are the numbers that can perfectly divide 6 without leaving any remainder. 6 divided by 1 will give you 6. 6 divided by 2 will give you 3 without any remainder. 6 divided by 3 will give you 2 without any remainder. 6 divided by 6 will give you 1. So from what we have here now, we can see that 1 is a factor of 6, and that is how 1 behaves. 1 is a factor of every number in this life. So then talking about 6 itself, 6 can also divide 6, meaning that every number is a factor of itself. There are 2 points now. 1 is a factor of every number in this life. And then every number is a factor of itself. So look at those 2 points. So now let's consider multiples. So I will define it the same way, but you just see yourself, you see the difference. So let's say the factors of the multiples of a number M. Let's say the number is M also, are the numbers that M can divide without any remainder. So the numbers that m can divide without any remainder are the multiples of m. Don't confuse this English. So this one says numbers that can divide m, but this one says numbers that m can divide. So don't confuse the two. Numbers that can divide 6 are 1, 2, 3, 6. But what about numbers that 6 can divide? Let's give that as an example. For example, multiples of 6 are the following. The numbers that 6 can divide begin from 6 itself. 6 is a multiple of 6. So if you add another 6, that will produce the next multiple. Now 6 plus 6, that will give me 12. 12 is also a multiple of 6. Plus another 6, that will give you 18. Plus another 6, you get 24. Plus another 6, you get plus another 6, you get 30. Plus another 6, you get 36. So, and it continues like that. So, what you can see now is that multiples continues. You cannot get to the end. So, multiples of every number are infinite. You can never get to the end of multiples. But when it comes to factors, factors have certain amounts. So like this one now, 6 has only 4 factors. No matter how many the factors of a number are, they are not infinite. They are finite. But as for multiples of any number are infinite. You can't get to the end. Can you see the difference between factors and multiple now? So we are done with this. Let's now see how we can simply find factors of every particular number. So, and also the multiples. So let's consider factors first. We see an example on how to find the factors so that you will not leave out any factor unwritten. So for example, question can say, find, this is how question is asked if you are asked to find factors. Question will say, find all the factors of, you can say Roman figure 1, let's say 48, and then the second question should be 60, for example, and so on. So let's see, I will teach you a method now that you will use to find all the factors of 48 and 60. If you say you just want to be writing them, like 1 can divide 48, 2, so try 3. So you may miss them out. But this is the method you will use in order not to leave anyone out. Let's come with solution. So for 48, I'm going to write 48 here. So I know that starting with 1, always begin with 1. So 1 times what will give me 48? That's 1 times 48. So after using 1, the next number after 1 when you are counting is 2. So try whether 2 will work in this situation. So I think 2 will work. So 2 times 24 is going to give us 48. So now the next number after 2 is 3. Can 3 divide 48? Of course, yes. So 3 times what? So you can divide 48 by 3. That will give you 16. So you divide 48 by 3 and see. So next will be 4. So can 4 divide 48? Of course, yes. That's 4 times 12. That will give me 48. So try 5. Can 5 divide 48? No. Reason is that any number that does not end with 0 or 5 cannot divide. So 5 cannot divide this. So what about 6? 6 times 8 will give me 48. 6 will also work. So 6 times 8 will also work. So what about 7? 7 can never work here. What about 8? So 8 times 6 is already here as 6 times 8. If you write 8 times 6, this is just like a repetition of 6 times 8. And we don't want repetition to occur. I will just stick to, I will stop at this one. Once you notice that repetition has started happening, you stop. So to write all the factors, I'll pick it from the top to the bottom and then from the bottom to the top. Therefore, factors of 48 is equal to write 1, 2, 3, 4, 6.
1, 2, 3, 4, 6. Then write all the ones by the right to 8, 12, 16, 24, 48. 8, 12, 16, 24, and 48. So these are the factors of 48. So I'm going to leave this for you as the student to try. So try this using the same method. Try the numbers one by one, 1, 2, 3, 4, and see the one that will work and the one that will not work. Once you see repetition occurring, then you stop and take your factors, write them out. Now, let me do one more example on multiple. So, the way questions are asked, if you are asked to find the multiples of a number, they can't ask you to list all the multiples, just like they said for factors, like write all the factors. They can't say write all of the multiples of a number. No, because you can't get to the end. So what they say is that they will say, find the first 5 multiples of the following number. Or they say, find the first 10 multiples. In fact, they can say, find the first 20. So they must put certain amounts. But for factors, they will say list all the factors. But now, let's say list the first 10 multiples of, let me start with number 1. Let's say 6. Okay, I have used 6 before. Let's use 8 this time around. Number 2, 13. So the first 10 multiples of 8 and the first 10 multiples of 13. I'm going to do this one and I will leave this for you as the learner to try. Solution. So see the method that we are going to use. Multiples of 8. Write this out. So that will be equal to, so you must start from 8 itself. All right, 8. So to know the next multiple, I'm going to add 8 to the one that we have on ground. 8 plus 8, that will give me 16. Add another 8, that will give me 24. So you keep adding 8 till you get to the 10th one, because it said 10 multiples. Okay? So this plus another 8, that will give me 32. If you add another 8, you have 40. Add another 8, you have 48. Add another 8, you have 56. Add another 8, you have 64. If you add another 8, you have 72. If you add another 8, you have 80. So this is the stopping point. If you count, this must be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the first 10 multiples of 8. I want to leave the second one for you to do as a learner. So you can do the second one and drop your answer in the comment section. Good. So please, before I proceed, if you have not subscribed to this channel, kindly click the subscribe button and like this video, comment, say good things about the video. So it's not always good to be learning in a particular channel and not subscribing. It's not good, it's wrong. Please kindly like this channel, click on the subscribe button. Subscription is completely free. You are not paying anything to subscribe. Just click subscribe. So my name is Sheikh Ridwan Abubakar. So I'll be teaching you mathematics in the best way and also science subsequently. So let's go to the next subtopic. I think we are done with this now. The next subtopic here is going to be prime numbers and the composite numbers. Good. So what are prime numbers? Prime numbers are numbers that have only 2 factors, 1 and itself. So a prime number. So let's say a prime number is any number that has only 2 factors, 1 and itself. So what this is saying is that that number that we are talking about, a prime number can only be divided by 1 and itself. So that's the meaning of this statement. That's why we say a prime number is any number that has only 2 factors, 1 and itself. So we have several examples of that in the real number system. So from 1 to 100, between 1 and 100, we have 25 prime numbers. Example, starting with 2. 2 is a prime number, and this is the only even number that is prime. So we have 3, we have 5, we have 7. So 8 is not, 9 is not, 10 is not, then 11 is the next. So 12 is not, 13 is the next, 14 is not, 15 is not, 16 is not, then 17 is the next, 19, and this continues like this. It continues like this because we can't get to the end of prime numbers too. Prime numbers are infinite. They don't have end. Very good. Good. How do we now know? Okay, let me now talk about composite number. Let's talk about composite numbers. Composite numbers. So, when we are talking of composite numbers are numbers that have more than 2 factors. Composite numbers are numbers that have more than 2 factors. So numbers that have more than 2 factors are called composite numbers. So examples of such number, the one that is very close to us is 4. 4 is a composite number because 4 can be broken down as 1 times 2, 1 times 4, and 2 times 2. So that means apart from 1 and 4, 2 can still divide 4. So another one is 6, another one is 8, another one is 9, 10, 12, and so on. We have many of them among numbers. So any number that can be expressed in this, let me just claim this and show you how we can differentiate between prime number and composite number. So good. How can we know that a number is prime and a number is composite? So once a number can only be expressed in one way, for example now 2 is a prime number, the only way that I can express 2 is to say 1 times 2, or I say 2 times 1. There is no other number apart from this 1 and 2 that will produce 2. So that means 2 is a prime number. The same thing can go for 3, the same thing can go for 5. So 1 times 3 or 3 times 1. Similarly, 1 times 5 or 5 times 1. So these are the only ways that I can write this number. So all of these numbers are examples of prime. They are prime numbers. But on the other hand, if there is another way that you can express a number, so apart from this way, then the number is composite. For example, let's say 4, for example. 4 is a composite number because I can write 4 as 1 times 4, and I can equally say 2 times 2. That will still give me 4. So both of them. So since there is another way that I can write 4 using 2 times 2, that means 4 is a composite number. Similarly, I can do the same thing for 12. 12 can be written as 1 times 12, 2 times 6, and 3 times 4. So you can see that if this one even have several ways of writing it. So that means these numbers are composite or composite numbers. That means 4 and 12 are composite numbers. Very interesting, very good. Now, then there are some points that I want you to take note of. I will use that to round up this class. So there will be part 2 for this particular class. There will be part 2. So now, how do we now find, okay, there are some points I want you to take note of. Facts about prime and composite number. Number 1, so 1 is not a prime number. Take note of that. 1 is neither prime, nor composite. So 1 is not prime. Why? Because prime numbers always have 2 factors, 1 and itself. Then 1 only has 1 factor, and that is just 1. And it is also not composite, because composite have more than 2 factors, and 1 does not even have up to 1, not up to 2 factors. So another one is 0. 0 is neither prime nor composite. So reason is that 0 is not prime, because 0 can be divided by every number in this world. Use any number to divide 0, the answer will remain 0. And it's also not a composite number. So because every number will work, so it means it's not composite. Let's go for the third one. 2. 2 is the only even prime number. So if you check the list of prime numbers that I gave you, so 2 is the only even prime number. So no other prime number that is even. Let's go for number 4. The last one that I will give here is that between 1 and 100, there are 25 prime numbers. Between 1 and 100, there are 25 prime numbers. So you can take the job, do it as an assignment. You can drop your answer in the comment section. So just for you, just to know that you are following this class, it's very good to always be active in a particular class. All what you have learned now, put them to practice and see and retain them in your head. My name is Sheikh Ridwanullah Abubakar. Please do well to subscribe to this YouTube channel as you are learning. So, and trust us, we are going to give more meaningful and educative content subsequently. Help this channel to grow, help this channel to be known worldwide. Thank you. God bless you.